here lately, we've been receiving a couple of different problems, especially in our Get More Math practice sets, where they are asking us to find the exact values. And exact values is when we want to leave things in the square root form and or unsimplified form. So what we want to look at is build up on using the trig that we've just learned on how to use those to solve for missing parts of the 30, 60, 90, and the 45, 45 right triangles. So remember, sine is still going to be the opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So here we go. So let's build up on this. So here we go. We have a 45, 45 triangle, and we want to identify the ratios for our 45, 45 triangle and leaving them in that exact format. So for starters, what we need to remember is that we do have an isosceles right triangle, and we know that that means our side ratios are 1 and 1, with our hypotenuse being the square root of 2. So with that being known, let's go ahead and do our sine. We do have our little remembrance here: sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. So there's that little reminder. So let's go ahead and list them. So sine of 45 degrees. Luckily for the 45, 45, we only have to do this once because, again, the other angle is the same measurement. So it turns out kind of nice. So the sine of 45, so again, here's my 45-degree angle. Opposite of 45 is 1. And the hypotenuse, which we've already identified, is the square root of 2. Now, if you plug that into a calculator, you would get the rough number of 7071. I'm not going to do that too many times, but I just want to show you that if you would look at our trig table, go to 45, and here is our sine. Okay, and you'll notice here in a moment that also the cosine is going to be the same, and then tangent 1. So let's just continue on with our exact values. All right, so cosine of 45 degrees, again, is also going to be adjacent over the hypotenuse, so 1 square root 2. And tangent of 45 degrees will be opposite over adjacent. And of course, 1 over 1 is 1. All right, so there are our ratio values. So what we're going to want to do is we're going to want to work with these exact values. All right, so let's look at an example. So we have our ratios written down here, nice and conveniently. All right, so let's label our triangle, which we always want to do. Here's our angle that's being given. We have an x value on the adjacent side, and we have a given value on our hypotenuse. So based on the adjacent hypotenuse, we're going to want to use cosine because, again, the cosine is calling for adjacent over hypotenuse. So with that, the cosine, and again, our angle measure is 45 degrees, will be equal to the adjacent side over the hypotenuse. So this time, instead of plugging into a calculator or any of that type of thing, we're going to use our ratios down here. And we have this 45 right here, which is 1 square root 2. So we're substituting that value in for our cosine value here. So the cosine of 45 equals 1 over the square root of 2. It's still equal to our ratio here of x to 16. So now we're just going to cross multiply. So x square root 2 is going to equal 16. We'll divide by the square root of 2. And x is going to be equal to that 16 over the square root of 2. Now keep in mind, Get More Math is happy with that, but we may need to go ahead and consider rationalizing it. And if you do rationalize that denominator, that would be 8 square root 2. But of course, again, Get More Math is okay with our 16 square root 2 over the square root 2. All right, so there's your 45, 45. All right, so let's try the same process with our 30, 60. So for our 30, 60, here's our 60 degrees. And we know that based on subtraction, well, our 30 degrees will be here. And of course, our hypotenuse is out here on the opposite side of our 90. Our ratios are 1 across from our 30, square root 3 for our long leg, and 2 for our hypotenuse. All right, so let's go ahead and again, let's set up our ratios. And we're again going to leave them an exact value. So now this time though, instead of like the 45, we actually have 2 different angles. So we have sine, and of course the sine of, let's start with 30. It's a smaller number, so why not? So opposite of 30 is the 1, and the hypotenuse, of course, is 2. Cosine of 30. So again, here's my 30, and we're looking there first, and that's going to be adjacent over the hypotenuse. And then the tangent of 30 is going to be the opposite side, which was 1 over 2. Whoops, sorry, no, adjacent. Excuse me, square root of 3. All right, so now let's repeat that process, but for the 60. So the sine of 60 is going to be, so this time again, we're looking from here. The opposite is square root 3 over our hypotenuse of 2. Cosine of 60 is going to be the adjacent side over the hypotenuse. And tangent of 60 would be the square root of 3 over 1. All right, so there's our ratios, and let's apply those to a problem and solve. Okay, so here we go, and luckily we have all of them written down here, so we're good to go. So let's again identify what they've given us. We are given the angle measure of 60 degrees. We are given the adjacent side, and we are also given opposite side of our 60 degrees. And our hypotenuse is not marked, so we're not going to need that for this particular problem. So for our opposite and adjacent, we want to look again at what trig function has opposite and adjacent, and that would be tangent down here, because opposite adjacent. All right, so let's go ahead and solve. So again, we're going to use the trig function of tangent. The angle measure is 60. And we are, again, opposite, which is x, over my adjacent side, which is 20. Looking at our functions here, tangent of 60, square root of 3 over 1. Equal to x over 20. So there's our proportion. And we can go ahead and cross multiply and solve. Or if you want to just multiply by the common denominator, you can do that as well. All right, so we end up with x equal to 20 square root 3. And you're done. All right, so let's try a few more sample problems. And again, this time we have 2 different types of problems. We have a 45-45 and a 30-60. And again, all of our ratios are written down below. So if you want a quick reference, you can also always Google a table or a chart, and they'll have these. And this only works for our specials at this point. So for everything else, we use our ratio values. All right, so for this one, we have a 45-45. And again, we're just going to base it on the fact that they give us this 45 angle, so we're going to stick with it. The side given is adjacent, and we're looking for the hypotenuse. So again, adjacent hypotenuse is going to be our cosine values. So we'll use cosine of 45 degrees, and that's going to equal the adjacent side over the hypotenuse. All right, so again, we can go down to our little chart that we have down here, and we find that the cosine of 45 degrees is 1 over the square root of 2 equal to 7 square root 2 over x. Again, cross multiply, and we find that x is going to equal 7 square root 2 times the square root of 2. And 7 times 1 is 7. Square root of 2 times the square root of 2 is 2. So x would equal 7 times 2, which is 14. And there is your answer. All right, so doing the same process for our 30/60 here. All right, so again, this time they gave us a 30-degree angle. And there's our 30. And we got the adjacent and a hypotenuse. Look at that. Cosine again. How about that? But this time for the 30-degree angle. So we're going to want to kind of follow along with our 30. And again, it's still an adjacent side with a hypotenuse. So we'll go ahead and use cosine. So again, the cosine of 30 degrees will be equal to the adjacent side, which is x, over the hypotenuse of 6. Our cosine value is down here, square root of 3 over 2 equal to x over 6. And what we'll do here is we'll go ahead and just cross multiply. So I end up with 2x equal to 6 times the square root of 3, divide by 2. And 6 divided by 2 is 3, square root 3. And we're done. I hope that kind of helps a little bit and maybe makes the 30, 60, 90s, and 45